All right, so zoom out, not in. 15E.1, excellent. So guys, today kinematics, and what we're doing then in kinematics, that word is just about motion. So we're actually going to be doing a little bit of physics. So can I see a show of hands who's doing physics at the moment? At year 11? Yep, one person. Cool. All right, excellent, Tyler. So, look, it's a little bit of physics, but really all we're doing is we're applying the maths and we're looking at an application of the calculus techniques. So that's good to know that we haven't had a lot of exposure to physics, so we'll go through it pretty slowly and emphasize some of these words for you. So firstly, let's have a look there. We've got displacement, all right? And we use displacement, we use S of t to represent displacement. So we have the displacement of some object with regards to time, all right? And so it's like you have y equals, okay? The displacement with regards to time. Now displacement is the distance an object is from its point of origin. So have you heard of the difference between distance and displacement? All right, you've heard about that? Distance versus displacement. So let's make a case for each, okay? So if I'm standing here and I walk 10 meters that way and then 5 meters this way, okay, 10 meters plus 5 meters, the total distance I have traveled is 15 meters. All right, I've traveled 10 to the right and 5 to the left. But my displacement is 5 meters because I am only 5 meters from where I began. So that's the difference between distance and displacement. Distance, how far you traveled in total. Displacement, how far are you from where you began. Okay, so that's the first point. Then we have velocity, right? So velocity is the rate of change of displacement. All right? If you think, when you talk about how fast is something traveling, it's always distance per period of time, right? It's distance with regards to time, the displacement with regards to time. So velocity is the rate of change of displacement. And I don't think we address acceleration here. That's more of a year 12 concept, but acceleration is the rate of change of velocity. Okay, so we've got a couple of formulas here. We've got average velocity versus instantaneous velocity. We've got average acceleration versus instantaneous acceleration. And when we're talking about kinematics, the key thing is we only consider positive values of time. So you don't need to consider any negative values of time. We only anticipate the model moving forward in a temporal sense. So let's get into the first example. Consider the displacement time graph alongside, where time, t is the time in seconds on the x-axis, and s of t is displacement in meters from the point of origin. Okay, so initially, so let's describe what's going on here. Initially, when time is 0, the object is at -2 meters. All right? When time is 2, the displacement of the object is 0 meters. And when time is, this point here is 3.5, the displacement is about 0.45. Okay? So that's what's going on. Displacement on the y-axis, time on the x-axis. Okay, find the displacement initially. So when time is 0, when on the x-axis we have time, when time is 0, the displacement is -2 meters. Have we got a unit? Time in seconds, meters on the x-axis. Yep, meters on the y-axis. Okay, and then part 2, after 4 seconds. So one way we could write this, I'll show you guys, is S of 0. The displacement when time is 0 is -2. The displacement when time is 4. And so I'm going, okay, here's 3.5, here's 4, it's about here. And you can see from the grid that corresponds with a displacement of 0.4 meters. Okay, so you're just looking at, we've got the t value is 4, what's the corresponding y value? That's going to be the displacement. Okay, find the average velocity from time is 2 to time is 3. Okay, so here the time is 2, and then here the time is 3, right? Here the time is 2, here the time is 3. We'll look at our average velocity formula. It says, I'll write it out and then I'll explain what it is. S of T2, take S of T1, on top of T2, take T1. What is that? That's the slope formula. Average velocity is just average rate of change on the displacement time graph. So we're just finding what's the slope of that chord. Well, the x value here is 2, the y value is 0, so that's the coordinates of the first point. The second point up here is the x value is 3, and the y value, when time is 3, is going to be 0.4. And so we just plug these in. Y2 take Y1 on X2 take X1. Average velocity is 0.4 take 0. Okay, Y2 take Y1. S of T2 take S of T1. Divided by 3 take 2. Okay, 0.4. Now, a rate of change is always y per x. And on the y-axis we have meters, and on the x-axis we have time in seconds. And that's what we expect, right? SI unit for velocity, meters per second. Okay, so that's part B over here, average velocity. Part C, find the instantaneous velocity when time is 3.5. So we've said here time is 3, here time is 4, here time is 3.5. Now if we want to find the instantaneous velocity, we want to know how fast is it moving at that point. We want to know what is the slope at that point. At that point. So one way we could do it would be to draw a tangent that touches at that point. What's the slope of the tangent at that point? 0. It's not increasing, it's not decreasing. At this point, it's stationary. Its displacement is not moving further away, it's not getting closer. The displacement at this point, so S of 3 point, the instantaneous velocity, this is V, the velocity of 3.5 is 0 meters per second. It's not moving, it's stationary. And we know it's stationary because the displacement is not changing at that point. All right, so that's the first one. So we'll be presented with graphing questions in the textbook, and then we'll be presented with equations as well. So on to the next example, we have S of t is 3t take 0.5 t squared. So we have the displacement of an object with regards to time. Okay, find the average velocity from time is 1 to time is 3. We don't have a graph, so we're not going to get the average velocity. We're not going to get those points from the graph, but we're going to use the function. We want to do average velocity from time is 1 to time is 3. All right? So that means we need the displacement when time is 1, and we need the displacement when time is 3. All right? Displacement when time is 1, displacement when time is 3. We'll plug those in. So when time is 1, I'm going to have 3 times 1 take 0.5 times 1 squared. And that'll be 3 take away 0.5, which is 2.5. All right, so when time is 1, the displacement is 2.5. And when time is 3, let's plug that into here. We'll have the displacement is 3 times 3. Take 0.5 times 3 squared. So that's going to be 9. Take away 4.5. It'll be 4.5. Okay, so all of that you can do on your calculator, right? Just type that in. This is what it'll punch out. So we have S of T1, S of T2, T1, T2. Doesn't matter what order we put them in, except to say If this is T1, then that's the time 1 value. All right, if this is T2, then this is the displacement in time 2. So let's put it in the formula then, and I'm going to do 4.5 take 2.5. So for average velocity, 4.5 take 2.5. Okay, S of T2 take S of T1 divided by T2 take T1. 3 take 1. And so we'll have 2 divided by 2, we'll have 1. And units, not told units, we'll assume meters per second. Okay, so just doing the slope. Now, look, we've done that without the graph, but if you were to graph this function, again, it's going to be an inverted quadratic. It'll look something like that. And so we're just doing the slope from time is 1 to time is 3. We're finding the slope of that, and we found it was 1. So that's all we're doing, except we're doing it without the graph. Okay, find the instantaneous velocity when time is 2. Okay, so for the instantaneous velocity, all right, the displacement function is 3t take 0.5 t squared. The velocity function is the derivative of the displacement function. Okay, the velocity function is the rate of change of displacement. So if we differentiate this with regards to t, all right, we're not differentiating with regards to x, doesn't matter what the variable is, we can still apply the same rules. So the derivative of 3t will be 3. The 0.5 is going to stay out front here because it's just a number, and the derivative of t squared is 2t. All right, we'll simplify that. It becomes 3 take away 0.5 times 2, 1 mod of t. That is the velocity function. Yeah, of course, yeah. Okay, now we want to know what's the instantaneous velocity when time is 2. So that means we want to know the velocity when time is 2. 3 take 2, 1 meter per second. Okay, so halfway in between time is 1 and time is 3, the velocity is 1 meter per second. Now the next two ask about acceleration. I'm pretty sure it's part of Year 12. Let's just have a look if they ask it, and if they don't, we'll go through it. E.1, displacement, velocity. They do in question 3, so we have to do it. Okay, so we've got, the next one says average acceleration. Okay, find the average acceleration from time is 1 to time is 3. So for average acceleration, acceleration is just the rate of change of velocity. So the formula for it is the velocity of time 2, take the velocity of time 1, divided by time 2, take time 1. All right, so we've got the velocity function over here. The velocity function is 3 take away t. All right, so we're going to do, first we want the velocity when time is 3. All right, we're doing the average acceleration from time is 1 to time is 3. So the velocity when time is 3 and the velocity when time is 1. If we put 3 into the velocity equation, we'll have 3 take away 3, which will be 0. And if we put 1 into the velocity equation, we'll have 3 take away 1, which will be 2. So, velocity equation, we want the velocity when time is 3 and the velocity when time is 1. Okay, now let's put it in here. It doesn't matter what order we do it in, but let's do 0 as the velocity at time 3, take away 2, divided by the time value, 3, take away 1. All right, so this will give us minus 2 on top of 2, which is -1 meters per second squared. Alright, so I feel like I've got a little bit to explain there. Acceleration can complicate it a little bit. So, we found the velocity function by differentiating acceleration, right? That's how we got it. And now, to find the average acceleration, alright, we're choosing 2 points in time. Alright, and then it's y2 take y1 divided by x2 take x1. It's just the slope on the velocity function. Can I point out something that's maybe a connection for you here? I've said average acceleration is the slope on the velocity function. This is the velocity function. This is the equation of a line. What's the slope of this line? What's the coefficient of the variable? -1, isn't it? We've got -1 log of t, and what do we find the slope to be? -1, so that's what we expect. Okay, last one, find the instantaneous acceleration. So this is going to be our last dot point, second to last dot point. Instantaneous acceleration. The acceleration function is the derivative of the velocity function. So what we're doing then is we're differentiating again. If this is our velocity function, 3 take away t, and the acceleration function is the derivative of the velocity function. All right, acceleration is rate of change of velocity. Velocity is rate of change of displacement. So we're just going to differentiate this again. The derivative of 3 is 0, and the derivative of minus t is -1. Okay? And this isn't a function, is it? This is just a horizontal line, y equals -1, which means the acceleration is always -1. So, to answer the question, find the instantaneous acceleration at time is 2. When time is 2, the acceleration is -1. Alright, we've said acceleration was constant. Remember, that would mean the average acceleration is the same as the instantaneous. So that's what we expect. And meters per second squared. Alright, velocity is distance per period of time. Acceleration, distance per period of time squared. Alright, so look, that last one did get a little bit tricky with these time twos and so forth, and going from the displacement to the velocity to the acceleration, but it will start a bit easier than that, okay? We'll start like our first example there, where we're just taking the information from the graph, finding the average rate of change. So that's what we dedicate our efforts to today. Anyone want to ask a question about what we're going through up here? Alright, let's see how we go with it.